Let's say you want to buy this specific Sony Vaio laptop. In fact, you want to order 10,000 of them all at once. You go to the order page, click the quantity box, and start typing. But after the third digit, your keyboard stops responding. The browser physically blocks a 4-digit number. This is a client-side restriction. It's a rule enforced entirely by your own web browser, running locally on your computer. Looking at the source HTML, we see how this barrier is built. The quantity tag restricts the length to 3 characters. But this local code is just a suggestion. The top form tag dictates data packaging, but lacks authority once data leaves your computer. Relying on the browser to enforce rules creates a structural vulnerability. What looks like a hard security wall to a normal user is actually an exploitable illusion. The simplest way around this wall is to let the browser enforce its 3-digit rule, but grab the data mid-flight before it reaches the server. We set up an interception proxy as a middleman. Your browser sends the maximum 999, but we catch that packet before it reaches the server. Inside the proxy, we edit the packet, changing 999 to 999,999, and forward it to its final destination. This works, but it's tedious. Since the local web page is still restricted, you have to manually catch and edit every single error you place. To gain true control and type freely into the web page, we have to intercept the server's code and change it before the browser ever has a chance to render the restriction. We do this using response interception. We refresh the page and configure our proxy to catch the server's inbound HTML document, allowing us to delete the max length code entirely. We look at the proxy's incoming traffic, and instead of an HTML document, we see this, a 304 not modified status code with a completely empty body. This failure happens because of caching. Your browser preemptively told the server it possessed a saved copy of the page, avoiding a new download. Looking at the outbound request, we see how the browser makes this claim. It attaches specific tracking markers, the if modified sense and if none match headers. So if the server relies on these exact headers to withhold HTML, how do we manipulate the proxy to force a fresh document? We strip the tracking headers from the outbound request while it's paused in our proxy. The server receives this modified request, assumes the browser has no memory of the site, and returns a 200 OK response packed with the full HTML document. Clearing cache roadblocks in transit is the mandatory gateway to altering client-side code dynamically. Now that the proxy holds the visible HTML response, we delete the max-length code from the form and pass the clean file down to the browser. Back in the web interface, the restriction is gone. You can seamlessly type an unrestricted 10-digit quantity directly into the local box without any errors. If the server blindly accepts this manipulated payload, the consequences are severe. A number this large can trigger database corruption, buffer overflows, or open vectors for injection attacks. This demonstrates the foundational rule of web application security. Any limitation enforced on the client side must be independently verified by the server. We can consolidate this into a repeatable 4-step checklist. 1. Identify the client limits. 2. Try a request intercept mid-flight. 3. If you need the page code, try a response intercept and strip the cache headers. 4. Test the server's validation. Mastering the exact flow of data and manipulating the rules at every node is what separates a superficial understanding of web forms from true security analysis.